Welcome. In this video, we are going to be looking at some division properties with exponents, which is something we've already kind of looked at with our negative exponents, but we'll continue to look at why do these things work and how can we utilize that those patterns to find some sort of rule to make it a little easier for ourselves. So just some notes to get us started here. When you're simplifying exponential expression, it is completely simplified if you have no negative exponents. The same base does not appear more than once in the product or the quotient, so I can't have an x to the fourth and an x to the second. Those need to be combined. There are no powers raised to powers. There are no products raised to powers, and no quotients are raised to powers. Also, any numerical coefficients in a quotient do not have any common factor other than 1. So what this is saying here is that if I have like 2/4, I need to simplify that to 1/2, right? We just need to simplify our fractions like we always have. Okay, so things that are simplified, right? These guys on the left here, these are all simplified. Versus these guys on the right are not simplified. So this one is not simplified because of this a to the -2 and an a. So two reasons there. We have a negative exponent and we have two of the same base. Here we have two of the same base, not simplified. Here I have a power to a power, product to a power, quotient to a power, and here we're not simplified because 10/4 we can simplify to 5/2. So all of those things we want to be looking for as we are simplifying. So today we are going to focus on some quotient of powers. So if we're dividing with powers. So we're going to go back to what does this mean here. So again, a to the 13th is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 factors of a in my numerator. And in my denominator, I have 1, 2, 3, 4, 5, 6, 7, 8 factors of a. And obviously we don't want to have to write this out every time, but thinking through what this means, it can be really helpful to figuring out what your answer is or what your simplifies to. So anything divided by itself is 1. So all of these a over a's will just divide out to be 1. And we're just left with 1, 2, 3, 4, 5 factors of a, or a to the 5th. Okay, thinking through this process is really helpful when we have something like this, a 5 to the 4th over 5 to the 7th. This is 4 factors of 5 over 7 factors of 5. So 4 of them divide out. Okay, anytime we're left with nothing in the numerator, really remember 5 divided by 5 is 1. So this is 1 over 5 to the 3rd, which is 1 over 125. Okay. So we want to make sure that when we're doing that dividing out, that can help us. So anytime we have a non-zero real number, we have a to the m over a to the n. This is just a to the m minus n. And I want you to use this rule really loosely and think about what it means. So here, technically, I would do 4 minus 7, but that would give me a negative exponent. So why not just think there are more factors of 5 in the denominator, so my leftover factors of 5 are going to go in the denominator. Okay, so let's look through a few examples here. Here I have an n to the 4th, n to the 3rd. So I have 4 factors of n in the numerator and 3 factors of n in the denominator, which means I'm going to be left with 1 factor of n in the numerator. I have p to the 7th and p to the 2nd, which means I have 7 factors, 2 factors. 2 will divide out, and we're left with p to the 5th. Okay, we could do 4 minus 3 is 1, and 7 minus 2 is 5 if we want to directly use the rule there. Okay, I could put an over 1 here, or I could just say that is my answer there because there's nothing left in the denominator. Okay, looking at our next one here, we have 3's, 3 to the 1st, 3 to the 2nd. So this is where I want to think. I could think about the rule and subtract, or I could just say there's 1 factor in the numerator, 2 in the denominator. So I'll be left with 1 factor in the denominator when I just divide out. 3 factors of 4 in the numerator, 4 in the denominator. So I'll be left with 1 factor in the denominator. 2 factors of 5 in the numerator, 1 factor in the denominator, so I'll be left with 1 factor of 5 in the numerator. Okay, and then simplify that a little further, we'll end up with 5 over 12. 5 and 12 don't have any common factors, so that's our nice simplified answer. Okay, here, couple of different ways to go about doing this last one here. You could use the rule and say 8 minus -2, it's the same thing as 8 plus 2, which is 10. So I have x to the 10th. Or we could deal with this negative exponent first and say that this is the same as x to the 8th times x to the 2nd, and then use our product rule there to say, here I have 8 factors of x times another 2 factors of x, which is 10 factors of x. So whatever works better for your brain. That's one thing that is great but kind of challenging with these exponent rules, is that sometimes there's lots of different ways to go about tackling it. Let's look at a few more here with the power of a quotient. So here we're just taking a quotient to a power. So this is very, very similar to our power of a product, that if I have something divided by something to a power, we're going to end up with that power to each factor in our quotient there. So if I have 4/7 to the second, again, you could think about this as 4/7 times 4/7, right? That's what it means to take something to the second power, which is the same thing as 4 squared over 7 squared, which is 16/49. 16 and 49 don't have any common factors, so that is our simplified answer. Okay, here we want to be a little more careful because there's lots of things here. Okay, if you get stuck, just do it out 4 times, but this is 3, that's my first factor to the 4th, times d to the second to the 4th, over e to the 4th, times f to the 4th, which is 3 to the 4th is, 3 times 3 is 9, 9 times 9 is 81, d to the power to a power, this is 4 groups of d squared, so d to the 8th, over e to the 4th, f to the 4th. Okay, don't have any like bases, can't simplify my fraction. No negative exponents, no zero exponents. Excuse me. Okay, this is where we get into some choice. I would start by simplifying everything on the inside first. You do not have to. You can deal with the outside exponent if you want to, but I would simplify everything here first. So I would say this is 2x to the third over x to the third, y to the third, right? Distribute that exponent. If you're not sure about that, write that as xy times xy times xy. I have 1, 2, 3 factors of x, 1, 2, 3 factors of y. Okay, this is why we simplify on the inside first, because it's going to make it easier, right? X to the third divided by x to the third, that is 1. So this is 2 over y to the third to the second. Now we have fewer things we have to take to that second power with our quotient rule. So this is 2 to the second over y to the third to the second, which is 4 over y to the 6th, when you have 2 groups of y to the third. So think back to what do each of those things mean as you are working through it. Ooh, negative exponents, putting that in. So remember that if you have a negative exponent, it's equal to the reciprocal of what you have. So instead of 3/4, I'm going to deal with the negative exponent right off the bat and say this is 4/3, right? Division becomes multiplication, multiplication, division, and now I can make that a positive exponent. Okay, this is 4/3 times 4/3 times 4/3, or 4 to the third over 3 to the third. 4 to the third is 4 times 4 is 16. 16 times 4 is 64. 3 to the third is 3 times 3 is 9. 9 times 3 is 27. Those don't have any common factors, so that is our simplified answer there. Hey, getting a little more complicated here. Check on the inside. Can I simplify anything in there first? Nope. Then go to your negative. Negative makes this y to the third over 2x squared to the second. Then everything, every factor to that power. So y to the third squared over 2 squared times x squared squared. 2 groups of y to the 3 is y to the 6th. 2 squared is 4. X squared squared, 2 groups of 2 is x to the 4th. Again, if you get stuck on any of those properties, think x to the squared X squared squared means x squared times x squared. If you're still stuck there, go back to what does that mean? X times x times x times x. Ooh, I have 4 factors of x. Okay, last one here, and this one is a doozy. There's lots going on. So again, I'm going to start on the inside and do what I can. Negative exponent, that's going to come down. Again, make sure you're not bringing the 3 with it. It's 3 times x to the negative 3. So the 3 stays in the numerator. Y to the 4th stays in the numerator. X to the 3rd, x to the 5th, y to the 3rd. Pick one more thing. I'm going to combine my x's. I have 3 factors of x times 5 factors of x. That's 8 factors of x. Again, if you're not sure, go back to what does it mean. Here I have y's. I'm using my quotient rule. I have 4 factors in the numerator, 3 factors in the denominator, which means I have 1 more factor in the numerator than the denominator. And we still have that 3 that's up there. Now that I've simplified the whole inside, now I'm going to deal with that exponent. So negative first, division becomes multiplication, multiplication becomes division. So this is x to the 8th over 3y to the positive 2. Then take that exponent to every single factor in there. X to the 16th, right? 2 groups of 8 over 3 squared. 3 times 3 is 9. Y squared. One little thing at a time until we get that whole list on the previous page done, right? No negative exponents, no zero exponents. We've simplified our fractions. We've simplified our quotients. We have done powers to power. We have no like bases, all of those things on that previous list. Okay, take it one thing at a time until you get to a place where you are simplified. Thank you so much for watching.